Okay, welcome to the February 2nd edition of the study hall. Today's topic is rate problems. In response to a few students asking about certain aspects of these, especially how do I name variables and how do I organize the problem and so on. So last time we did some problems that were about speed conversions. We're not so much going to be dealing with conversions today, but we're going to be doing rates. So we got to start out with the usual stuff. Let's try to make it quick. First, please don't submit problems that are too general. We had a lot of this past week. We had people saying things like, how do I solve problems faster? I mean, not really something that we can answer in a single study hall, because how do I solve problems faster would be basically every single problem on the whole test. So that's not something we can reasonably answer. Also, please don't submit problems that are too specific. We've had a bunch of people doing that as well. Please don't. And then finally, please don't submit personal study plans. That's not the point of the study hall. So for instance, let me show you, here are some submissions from, in case any of you are here. Here are submissions from the last week that we can't use. Okay, here's one. Someone wrote this. Someone wrote, it'll show up on your board in a second. I have 1 month left until the test. How can I best make use of my time? This is not the kind of thing that we do in the study hall. Okay, please no personal study plans. So that's not what the point of this study hall is. This is a program that's watched by hundreds of people, in fact thousands. So it wouldn't make sense to talk about one person's study plan here. Where you should post this stuff is you should post this in the general questions folder of the forum. So the forum is manhattangmat.com/forums, and you should find the general questions folder for that kind of thing. Here is another one that we can't really use. This is something you should put on the forum as well. So someone wrote this. There's two things wrong here. The first thing is that this is just a specific question. This is one specific problem. Like there's no connection to a general theme. So this is exactly why we have forums. This is why forums exist. We have forums so that we can answer random specific questions. It's not the point of the study hall, so please don't submit things like this. So this is an MGMAT book, so you would post this in the MGMAT folder. The other thing is you can't just give us a problem number like this, because we don't have all these books just laying around everywhere. So make sure you, when you submit a question, you actually have to submit the question. So meaning you actually have to give us the question that you're submitting. You can't just say page number, problem number, because when we make these study halls, we're not always somewhere where we have the books available. So please type the question. And then if you have a specific question, you have to connect it to a general theme. So there's that. And then probably the most questionable submission that we've had in the last couple of weeks was this. Someone wrote in drill number 4 on number 2, page 56 of McGraw-Hill's Conquering GMAT Verbal. I mean, I don't know what's going on here, but I think whoever submitted this must assume that we have all of these books. We don't. Like, we don't have random books by companies that are not us. So we don't have this book. So if you submit something like this, the first thing you have to do is you have to type out the question, but then you also have to connect it to a more general theme. Otherwise, just please post it on the forum. So, smiley face if this makes sense, because this last couple weeks was particularly bad. Like, most of our submissions in the last couple of weeks were things that we can't use. So, smiley face if you guys understand these rules. Can remember the smiley faces over there on the left. I don't know if anybody here is one of the people who posted these, but if you are, then make sure you know why we cannot use these questions. All right. These are not good. And then we had one person who also basically just asked us, like, how do I solve math problems? We can't do that either because that's too general. Okay. There's that. So that's the rules. Also, the last thing, please check the archives. So we have a very, 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 very extensive archive of these sessions by this point. I think there are something like 50 sessions in the archive, give or take a couple. So 50 is a lot. What this means is that we have done a lot of things already, and unless there's a new angle you have on the topic, we don't really want to repeat things. So please check to make sure that we haven't already covered your topic. We got a couple of submissions in the last couple of weeks that are totally things that we have done 2 sessions on already. So if it's that, then, you know, please watch those archived recordings. And then if you still have some sort of theme, then please specify what that is. So, for instance, we had a session on rate problems before, but a couple people asked specific things about rate problems that we hadn't really covered. So that's good. But please check the archives. Okay, any questions about the rules? Those are the usual smiley face if all the rules make sense. Again, the smiley face is in the left-hand side of the screen under the names. Okay, good. I see one person typing. There's a question in the text box. Can we find out what specific questions are covered? The only way to do that would be to watch the recording. So please do that. Because a lot of the time I pick and choose from available questions. I've even made up a couple on occasion. So, but there's no inventory of questions like that. All right, other questions? If you have them, go ahead and type. Otherwise, we're going to go ahead and get started. Okay, so lastly but not leastly, remember when we have questions in live, when we have live questions, please use the answer buttons to answer the question. Those are, you don't have those yet, but you will have them right now. So you should have answer buttons. When you, oops, I didn't mean to do that. Okay. When you answer the questions, please use these buttons and please click your answer exactly 1 time. Please do not type your answer in the text box, and please do not double click. If you double click, it will erase your answer. The first click answers it, and the second click unanswers it. So please click a single time. Okay, so there's the answer buttons. So everybody, smiley face if everybody has those on their screen, answer buttons. Okay, good. So remember today's theme is rate problems continued from last time. So let's go ahead and do one. I'll put a timer on the screen. Please remember to use the answer buttons. So here you go. There's a problem. Please use the answer buttons. I'll give you about, before we get started, just quickly, how much time do you think you should take on this? Text box. I mean, we'll put this problem back on the board, but a couple people are saying, most people are saying 2 minutes. Yeah, let's look at something. What I'm going to show you is 2 problems from the official guide. Actually I'm not going to show you official guide problems because I can't. What I'm going to do is put 2 problems on the board real quick, and we're going to talk about timing. So the issue here is how much time should I take on quant problems? So what is 2 minutes? Like, tell me in the chat box, 2 minutes is what? Like, what does that actually represent? Okay, yeah, 2 minutes is an average time. So that means average. I mean, this is not the amount of time that you want to spend on every single problem. So just think about the average of anything else. Like, let's say that you paint houses. If the average time that it takes you to paint a house is 4 hours, then you do not take 4 hours to paint every single house that you paint. I mean, if you have a giant mansion to paint, you'll take more than 4 hours. And if you have a little tiny bungalow to paint, you will take less. So, but overall, your average is going to be, about 4 hours. So same thing, the point here is that if you see, like, what kinds of problems should you allow more than 2 minutes? What do you guys think? Yeah, if there's a lot of words. I was waiting for someone to say hard problems. Hard problems is the wrong answer because you will not know which problems are hard. Like you as a student, you won't know the difficulty levels. There will totally be problems that seem easy that are hard, and there will totally be problems that seem hard that are easy. So you can't do it that way. Also, if a problem is really, really hard for you, then you should quit earlier, not later. So that's actually kind of the opposite of the way it should be. But it's the length of the problem. If you see a problem with lots and lots of words, then it's perfectly okay to take over 2 minutes. I mean, you still shouldn't go crazy, but like 3 minutes, 3.5 minutes, those are okay. On the other hand, if a problem is really short, especially if it's problem solving, not data sufficiency, you should take less time. Also, if you don't understand a problem, then you should guess faster. So one person in the chat box was saying I should take more time when I think that things are hard. That is actually exactly the opposite of what you should do. The way to do well on this test is to quickly let go of the things that you're not really understanding so that you can spend more time on the stuff that you do. So what I'll do is I can't put official guide problems on the board, so instead I'll just give you a couple of them to look at. You don't need to look at them right now. Look at the following at some point when you have the time. Look at official guide 12, problem solving number 163, and look at problem solving right under it, 164. Okay, I can't put these on the board, so I'm just going to talk about them and you can check them out later. But problem solving 163 is really, really long. There's lots of words and there's lots of interpretation. So everyone, and I mean everyone, including veteran GMAT instructors, is going to take more than 2 minutes to solve this one. If you give yourself 2 minutes for number 163, then the long and short of it is you're just not going to solve it. Problem solving 164 is really, really short. Everyone should be done with this one in something like 30 to 40 seconds max. And that means whether you understand it or not. If you understand number 164, you should be able to do the math in this much time or less. And if you don't understand it, you should, within this much time, say, oh, well, I don't understand it, and guess. So if you don't have the official guide on you, look at these later, but 163 is really long and 164 is really short. And I mean, if you're thinking exactly 2 minutes each, you're going to run into a lot of trouble because you're not going to have time to solve things like 163. But then 164, you're going to be sitting there staring at it for an unnecessary amount of time. So, but here's the deal. If there are a ton of words, then take more time because you have to get through the words. The worst thing you can do on a problem like that is hurry. So smiley face if this stuff makes sense. Timing considerations. Okay, good. So let's look at the problem that was on the board. So because there are lots of words, I'll give you a little bit of extra time. So let's say to, I don't know, 2:45 or so. So go for it. Okay, only about half you guys have answers to this problem, so let's get answers from the other half of you. Remember, this is the GMAT. The GMAT does not allow you to not answer things, so even if you are guessing, you got to make sure that you guess. So go for it. Okay, we still don't have guesses yet from Lovi, Madhu, and just those two. So if you are Lovi or Madhu, you should guess. If you don't, then just remember it's not real preparation for this test. So Madhu, you're the only one who hasn't answered yet. You shouldn't answer. Okay, well, we can't wait any longer. So here's your class statistics. Okay, so there's not a ton of agreement here. We do have an answer E that people like, but let's take a look. So we're going to look at this problem in many different ways. By the time we're done, you're probably going to be very sick of seeing this problem. But we're going to solve this problem in a few different ways. The first thing I want to do is talk about an algebraic approach. And before we talk about an algebraic approach, let's remind you guys of some things. It's a reminder if you saw this session. If you didn't see this session, then it's kind of a new important point. But reminder from the organization study hall. The organization study hall was on December 1st. When you see a lot of words in a problem, did anybody here see that study hall? When you see a lot of words in a problem, what should you do? If you saw that, then see if you remember the basic point that you'd put in the box. The first thing you want to do is read through the problem and ignore the math. You want to read it twice. The first read through, you ignore all math. Just ask yourself, I'm not sure what UPS means. Maybe you could explain. Ignore all math the first time you read. Just ask yourself what quantities are in the problem. And like what generally is happening. And from these, understand the situation. You're ignoring the math, and instead what you're doing is understanding the situation. Because, I mean, there's no point in doing any math if you don't really understand what's going on in the problem. You shouldn't just be slinging around random equations. So, understand the situation first. And based on these things, you can make a table. So from just what quantities are in the problem and what is happening, you can make a table. In the case of rate problems, making a table is a little bit more trivial because rate problems kind of always have the same table. Like it's always rate times time equals distance. So it's not as hard to make a table in these problems. But in any word problem, you should make a table before you even start looking at any mathematics at all. So there's that. What quantities are in the problem and what's going on. Now, once you do that, you should go back and then start using math. So let's do the situation first. Like, what's going on in this problem? Because if you missed this, or if you had to guess, I'm sure a big part of it was that you didn't really realize what was happening before you started writing equations. So, okay, Adrian starts walking from point X towards point Y, and then later James starts from the same point X and has to catch up. So the deal is that, Adrian leaves first. So this is point X and point Y. Then you have a situation where, Adrian starts and walks by herself for a while. So let's say that she gets somewhere. So Adrian walks a certain distance all by herself. And then once she reaches a certain point, James starts walking. So she's here, James is here, and then they get to the same point because James is walking faster. And this is what's happening in the problem. So this is the situation. So these walks here are simultaneous, but that first, Adrian gets a head start because she walks by herself. If you did not realize that this is what's going on, then that means you got into doing math too early, and you were not thinking about the problem. You're not like, what's happening in the problem? Because the fact that they walk 60 miles, absolutely unimportant here. It actually doesn't matter at all. Because nobody is going to make it the whole 60 miles. Like, they're going to catch up at some point that's in the middle of the path, and then they're done. So smiley face if you understand that this is the situation. Okay, so that's the deal. So let's carry this over to the next page as well as the picture. So let's talk about a couple of algebraic approaches. Here is what happened. Let's get that over here. Okay, so here's your picture. So the table here is pretty easy to make because it's just a regular rate table. So the table is going to be what quantities are in the problem. Well, it's just the rate, time, and distance for these two people. So you have R, T, and D for James, and you have R, T, and D for Adrian. So you can make a table. So let's do that. Rate, time, distance. Then James, then Adrian. And I mean, if you even need the table, which we'll talk about in a second, but you should make it. If you come up with some alternative way to solve it, then good, but otherwise make the table. The point is that you can do all of this work before you even think about mathematics in any way at all. So you should figure out that situation and that table. Figure out this situation and make this table before you do any math. Very, very important. I mean, this is what people do in everything but academics, right? Like if you were planning a diet, meaning, you know, I have calories and grams of protein and fat and stuff, the first thing you would do is exactly this. You'd say, what are all the quantities? Well, I have calories of fat, grams of fat, calories of protein, grams of protein, calories of carbohydrate, grams of carbohydrate. And then you figure out how they're related and what they do, and then you start doing math. Like nobody would start plugging in random numbers into a diet before they knew what was going on. And so you shouldn't do the same thing here either. So now let's talk about math. So concrete numbers, we know that Adrian walks 3 miles per hour. And this is going to be hours, and this is going to be miles. James is just 4. It's 3 plus 1. Another very, very important lesson. How many variables should we use to do algebra here? We should use 1 variable because there's a relationship. So if you have we've talked about this in a couple of previous study halls, but you should use 1 variable, not 2. Because otherwise you'll have to eliminate the second variable. So we know that Adrian walks for, like, what's the relationship between the times here? Chat box, if you know. How are these times related to each other? Yeah, Jay says equal. They're not equal unless you're just doing this for this part of the problem. So maybe. But it will. Right now we're talking about the whole problem. So Adrian walks by herself for 1 hour, and then they walk simultaneously for some unknown number of hours. So Adrian's time is longer. So it's not 4/3 times TJ. That's incorrect because they're not walking for the, they're not 4/3 times TJ. Actually that will be right. That'll work because Bruno writes TA is 4/3 TJ. If you know that, that's a very deep realization. That's not a trivial fact at all. Let me just digress and address that for a second. But yeah, that should work. I don't want to do the problem using this, but I'll just comment on it really quickly, and then I'll erase the comment. These are meant to be subscripts. So this is Adrian's time. Quick comment. It's not a join time. This is Adrian's time is 4/3 times James' time. This is true because the speed ratio is the opposite of that, and the distances total are the same. Okay, so Bruno, if that's why you're thinking that, then you're right. If you think that you can write that in any problem, then you're not right. Because if they walk different distances, then this would be false. But that works. I don't want to do the rest of the problem like that, but that is something that does work in this particular problem. So, but it's not a easy realization to make. So let's let that rest. Okay, back to what we have. So Adrian walks for an hour longer than James does. So that's a relationship. The relationship is Adrian takes 1 hour longer than James. So we should use that to make variable where you have your choice. I mean, you can make this t and you can make this t plus 1. You could also make this t and you can make that t minus 1. It really doesn't make any difference as long as you keep track of who is t and who is not t. So, smiley face if you understand the t and the t plus 1. You could just as well have done t minus 1 and t. So, then the point of an RTD table is that you can fill it in. So 4 times t is 4t. 3 times t plus 1 is 3t plus 3. So the total distances are the same. So you can write 4t equals 3t plus 3. If you solve that, you get t is 3 hours. You want James's distance, because that's what the problem asks you for. So that's going to be, from the table, it's 4t. So that's going to be 4 times 3. So E. So this is one way to do the problem. If you have any questions about this particular approach, please type them in the box. Not about other approaches yet, just this one. Okay, someone's typing something. Okay, we're going to do about 4 other approaches here. With t minus 1, it'll be a little different. This would be 4t minus 4, and this would be 3t. But then you'd get a bigger answer for t. Like when you plugged in at the end, it would still be 12 miles. So you would get t is 4 instead of t is 3. Okay, let's look at another way. Here is, let's say that you decided to just think about this part of the problem. Let's just set it up with this part. The reason why we can do that is because that first part doesn't have any unknowns here. I mean, we know that Adrian walks for 1 hour, which means so she walks for 3 miles because her speed is 3 miles per hour. So everything about that part of the problem is known, because it's 1 hour of walking and it's 3 miles. So if you just think about this part of the situation, now what you have is this. Now you have the same walking time. And then you have James walks 3 more miles than Adrian. So we can set up the same kind of table, but a little bit differently. So these are still 3. This is going to be Adrian and James. And this is going to be rate, time, distance. These are still 3 and 4. But now it's the same walking time. So we can just let this be t, and so this will also be t. That makes this 3t and 4t. It's the same walking time because this is when James starts to walk, and then they're walking together until James catches her. So this is all happening at the same time. If two things happen at the same time, then they take the same amount of time. Okay, so this is 3t, this is 4t. We have James' distance is 3 more miles than Adrian's distance. So 4t is 3t plus 3, same equation we had last time. So answer is James' distance, which is 4t, is 12 miles. So you can do that. Any questions? Okay, you can also use what are called relative rates. I will refer you to the strategy guide for a discussion of relative rates. Maybe we'll talk about that here at the end if we have the time. That would d minus 3 over, that would also work. I mean, it would be a little bit more annoying than this math, but yeah, that would also work. Okay, let's look at another way to do it. Another tool you have on rate problems. Let's say you might call this the third grade method. Let's say you're in third grade. Let's say you're kind of a smart third grader, so you understand what rates and such mean. Like you get that 3 miles per hour means that every hour you walk 3 miles. But since you're in third grade, you don't really know what fractions are, and you definitely don't know what variables are. So does anybody know what you could still do on this problem if you were in third grade and had that level of knowledge? Nobody. Say it back many, many years ago. Jay, what do you mean by count? What would you count? Yeah, you could just make a list, right? Yeah, like what Lawrence is saying too. You could totally just make a list of what happens at each hour interval. So sure, right? So James and then Adrian. First hour, James goes nowhere because he hasn't started walking yet, and she just walks 3 miles. Now the deal here is that she walks 3 miles every hour. So her distances look like that, and he walks 4 miles every hour. So his distances look like this. And this is our hour intervals. So the question is, these are distances from the starting point. So what we're looking for is we're looking for where they catch up. So there's your intervals of time. Where they catch up, well, it's where they're in the same place. So that's here. So here, James catches up to Adrian. So it's 12 miles. You can do this on a lot of these rate problems. You can't do it on necessarily every single one of them, but you can just kind of think about what would happen in whatever amount of time. So without using, yes, that's a coincidence. Okay, so let's see. Holdino says, wouldn't this take a lot more time if they didn't catch up this early? What point are you trying to make here? Are you saying that's a reason not to do this? I mean, I'm trying to figure out where you're going with that. I mean, in the meantime, let me address this comment, because this comment reflects exactly the wrong mentality to have on this test. So let's discuss this real quick. We're waiting for an explanation here, but this seems like it's a reason that somebody says, I don't want to try this. And that's exactly what you should never do on this test. This is a very bad attitude to have on the GMAT. Remember, the GMAT has a very severe time restriction. So what this means is that your attitude on the GMAT should be, if anything even might work, then I should know how to do it. So, I mean, yeah, if you were walking like some weird fractional distances in hundreds of miles, then it would take you a little while. But, I mean, still not really. I mean, like, even if you had to make this list for 20 or 30 rows, that would still only take you about a minute. So, number one, I think, yeah, see, if you had to get to 144 miles, you could still very, very easily do that within 2 minutes' time. That would be absolutely no problem at all. I mean, if you don't believe me, then try it. Because, I mean, you can make a row of this table in like a second and a half. So it's really, it's not something, it shouldn't discourage you from trying this method. Like, you should, like, really, you should just try something. So, I mean, I'm glad you brought that up, because it's always a good thing to reiterate this whole thing about how you should approach the test. Like, one thing that you should never do, ever, 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 is sit there and wonder how long something would take. Don't ever do that. This is not addressed at Holdino. This is addressed at everybody. Instead, what you should do, you should just try whatever you can think to try. And if it doesn't work, or if it's obviously going to take 10 minutes once you start it, then quit. So, Lawrence, it's a method. I mean, a method is a method is a method. I wouldn't even worry about last resort. I mean, you should learn as many ways as you can to do these problems, you know. So you shouldn't rank order the ways, because if you do, then what will probably happen is you'll just disregard the ones that you consider less important. And so every method is just as important as every other method. I mean, if you have a really formal schooling background, you probably don't like this method very much, but it doesn't matter. It's still a really good way to solve problems. So basically a third grade method is just think about concrete numbers after concrete intervals of time, so that there's no algebra. Okay, any questions? Okay, so think of all the lessons that we learned here. Let's kind of aggregate those on a single page. So what have we learned or reviewed, depending on your background? So like, what have we learned / reviewed about rate problems from this example? The first is more general advice for word problems. In long word problems, you should read them twice. The first time you should read is just to get to know the situation, what quantities are in the problem, and what's going on. No math. And this is where you make a table if necessary. Then the second time you do math. Another thing we reviewed was that if you have a relationship between two quantities, then use one variable, not two different variables for those quantities. And then finally, don't forget about the third grade method as an alternative approach on rate problems. Okay, questions, go ahead and type them in the chat box, otherwise we'll look at another problem. Okay, let's look at another problem. Let's take a look at this one. Here's a timer. Okay, sorry about that, ladies and gentlemen. That's 3 minutes. In fact, it's a little bit more than 3 minutes. So please answer the question. Thank you very much. Okay, there's still a lot of you who do not have answers. Remember that this is, we're almost 4 minutes at this point, so you gotta just get something written down, guys. Gotta get a guess. Okay, let's take a look. If you are Satish or Vinitha or Rejul, I don't really know how to pronounce these names, Bruno, please answer the problem. Okay, if you are Bruno or Rejul, remember that you're not prepping for the GMAT if you let yourself leave things blank, or Anand. You guys haven't answered it yet. This is not a test where you are allowed to not answer things, so keep that in mind. But let's move on. Here are people's answers, pretty good. So the first thing we should do is get the situation. The situation is, if you were here late, maybe you don't know, but there's answer buttons. The answer buttons are on the left-hand side of the screen. They look like this. So that's where you indicate your answer to the problem, if any of you guys were late. Okay. Now you know. All right. So there's a situation. Let's make a table. Let's get the situation. The situation is you have Kyoto and you have Tokyo. And at 12 noon, so at some time, a train leaves here. And at another time, which is later, a train leaves here. So this train departs from here, and this train departs from here 10 minutes later. And then they pass each other, which is the same thing as when will they meet. So that means that you have some sort of situation like this. Now let's do math. But what do we know about these distances? So what do we know? Well, we know that the total distance is 300 miles. So what else is 300 miles? Text box. Like, because that's the distance from K to T, what it has to equal 300? Total distance times the sum. So therefore, the sum of the two trains' distances is 300 miles. And then we know that the time for the blue train is 10 minutes less than the time for the green train. That's what we know. So now we can do math. Let's do math only after we figure out all of that. So rate, time, distance, blue train, green train. So there. Let's put those in the same order that they're in. So first green, then blue. Rate, time, distance. Oops, I didn't mean to do that. Let's do that here. Okay, rate, time, distance. So now we have problems. We have problem here because this is minutes and this is hours. So everything is in hours right now. So let's just do that. But we have to realize we got to convert at the end. So the rate will be miles per hour. The time will be hours, and the distance will be miles. So these rates, the green rate is 240, and the blue rate is 160. Someone give me some time variables. You can use t. Can you use t and t plus 10? Aha, t and t plus 1/6. Watch it. Again, watch for conversions. The good thing about not doing conversions is that if you are thinking about the problem with any sort of common sense, you'll realize when something is wrong. Because if you do this with the wrong numbers, then it will be so ridiculous. I mean, t plus 10 would be 10 more hours, and so you'd wind up talking about thousands of miles, which doesn't make sense. So you can use t and t plus 1/6, or you can use t and t minus 1/6. You're fine either way. So if you use t and t plus 1/6, then t is the shorter time. So that's the blue train. And then this would be t plus another 1/6 of an hour. You could very well also use t minus 1/6 here and t here. So Cheyenne, yes. So multiply, that gives you 240t plus 40 and 160t. And then you have this relationship. So there. Notice how much easier this is, or how much better this is, if you figure all of this stuff out ahead of time. This is why you want to read the problem twice. Because if you're figuring this out as you go, it's very hard. So if you have lots of trouble with rate problems, what that probably means, sorry, typo. If you have trouble with rate problems, what that probably means is that you are not figuring everything out before you start writing equations. Remember that writing equations should be the very last thing you do after you already understand everything that is going on. So if you do this, we have 400t plus 40. So 400t is 340. So t is 34/40, which is 17. 17/20. 17. Now, is that right? Yeah, I made a mistake. So let's talk about that mistake. Why did I make that mistake? Text box. I made a mistake, honest mistake. Why? I added instead of subtracting. Why? Why did I do it? Because I skipped a step. That's why I did it. Don't skip this step. Minus 40, minus 40. Do not do steps in your head. Because I tried to, I got it wrong. Write everything. So thank you guys for catching that. So 400t is 260. But yeah, it's very, very important to not ever do any steps of mental math. I know it's tempting because, oh, hey, mental math, it's so nice. But that's how mistakes get made. When people try to do math in their head, don't do it. So t is, thank you guys again, t is 26/40, which is 13/20 of an hour. 13/20 of an hour is 1/20th of an hour is 3 minutes, so this is 39 minutes. But notice this is 39 minutes after this departure, because t is the time for the blue train. So the blue train started at 12:10, not at 12 o'clock. So it's 39 minutes after 12:10. So that's B. If we were evil people, we would have had 1239 as an answer choice. This is one of the problems in our strategy guide. But we, I guess, decided not to be that evil. Okay. If anybody has questions about this particular approach, please type them in the text box. Why did I use t plus 1/6 for the first train? Well, you can't ask that by itself, but it's like, why did I use this pair of things? It's because of this. It's 10 minutes later. So this 10 minutes is a sixth of an hour. So this train is going for 10 minutes longer than that one is. So you add that much time. You could also have made this one t, and then this one would be t minus a sixth of an hour, but you would still have to do the sixth of an hour. Okay. Other questions, please type them in the box. Let's see, someone is still typing. While you're typing, let's start looking at another way. Does anybody know another way they can do this? Yeah, we did. We had to do it at the end. We had to. That's why we started with 12:10, and not 12 o'clock. Yes, you do have to add the 10 minutes. Where does 40 come from? It's multiplication. You're multiplying this quantity by that. So 240, you have to distribute it. So 240 times t is 240t, and 240 times a sixth is 40. I mean, I think that's the 40 that you're talking about, because I don't see any other 40s. Okay, a couple people are still typing, so let's see what they're saying. If you can type fast, that would be awesome. You know, if you have to, you know. Okay, let's talk about this. There's no reason to do long division. If you're going to do if you're going to do this, you don't do long division. I mean, the way I did this, so the question that you're trying to figure out is how long in minutes is 13/20th of an hour. So the way I did this was I just figured 1/20th of an hour is 3 minutes. So 13/20th of an hour is 3 times 13 is 39 minutes. So that's nice and quick. On the other hand, if you have to do math, it's still not long division. If you have to work this out, what's the math? Like, how do you convert something to minutes from hours? Nobody? Like, what's the math that you would use to do this? Yeah, you do it times 60. So you'd be doing 13 over 20 times 60. So there's no long division here necessary because this is still an integer. Like 60 divided by 20 is just 3. So you're off the hook. I mean, if you still had a decimal here, then yeah, but they're not going to do that to you. They're not going to make you do work with decimals in the middle of a rate problem, because that would just be kind of, given a time limit, that would just be ridiculous. So no, you're not going to want to do long division. Okay, let's talk about something else. How can we do this using no algebra? What can we do? You can do combined rates. Like I said in the last problem, I'm going to defer combined rates to the strategy guide. So see the strategy guide for a discussion of combined rates, because the discussion of combined rates in the strategy guide is excellent. So check that out. Yeah, you can do the third grade method again. In chunks, perfect. In chunks of 10 minutes at a time. So you can use the third grade method again. But, 1 hour chunks are too big. So instead, let's do chunks of 10 minutes. So train A, the train from Kyoto, is going 240 miles per hour. So that's 240 miles per 60 minutes, which means it's going 40 miles per 10 minutes. You just divide by 6. And then the train leaving Tokyo is going 160 miles per 60 minutes. So this is not as nice, but if you divide by 6, you get, what is that? That's 28. 25. 26 2/3 per 10 minutes. Let's do this per 15 minutes, because that's ugly. So let's say every 15 minutes. That would be 1/4 of an hour. You're just dividing by 4. And then this one also divides by 4. So that's 40 miles per 15 minutes. So yeah, we don't want to divide 160 by 6, at least not in this kind of method. Because remember, you're in 3rd grade, you don't know what fractions are yet, so you can't use them. Okay, so we have that. So let's just do this. Well, okay, the 10 minutes here is kind of an issue, but still, let's see. Okay, so 12 o'clock, 12:15, 12:30. 12:45, 1 o'clock. Yeah, okay, we need 12:10. So unfortunately, let's go back to doing 10 minutes. We should have stuck with what Jay said the first time. Sorry I didn't listen to you, Jay. Okay, so we're going to make this per 10 minutes again. So that's going to be 40 miles per 10 minutes, because you're dividing by 6. And that's going to be this ugly, horrendous 26 2/3 miles per 10 minutes. So, sorry I didn't listen to you. Okay, so then we can use the 12, because we have to have 12:10 in our table, because 12:10 is when the other train leaves. So if we don't have that, then it's bad news bears. So let's go ahead and take a look. So 12 o'clock, the Kyoto train hasn't gone anywhere, and neither has the Tokyo train. So this is 0 miles and 0 miles. At 12:10, the Kyoto train's gone 40 miles, and this train is still chilling, because it doesn't leave until 12:10. At 12:20, it's 80, 120, 160, 200 miles. And then this train has gone 26 2/3 of a mile, 52 4/3 is 53 1/3 of a mile, and then that's 90 miles. And then it's 116 2/3. So 100 yeah, I'm bad at math. That looks like it's 80, and that looks like it's 106 2/3. Okay. So what are we looking for in these numbers? Like what should happen? Yeah, we're looking for a total distance of 300 miles because, again, it's really, really important that you figure out this situation first. If you have this situation figured out, then it's no problem. You're like, oh, those are distances. I know what the distances have to do. They have to be 300 miles. So that is what happens. So this is less than 300 miles by quite a bit. And this is way more. This is only a little teeny bit more. So this is way too small. And this is a little teeny bit too big. So we know that we want a little bit before 1250. And so that means that we're looking at B. So yeah, pick the closest answer choice. Any questions? No, you don't have to actually even have the desired value in the table. Like the desired value is 300 and 300 is not in the table, but we don't care because we know that it's really close to that, and that's good enough. Any questions? Questions? Lawrence, I guess you're new around here. What is the difficulty level is the most pointless question that you as a student could possibly ask. Like, you should not ever think about that. It cannot possibly help you in any way. So, unless the only people who should think about difficulty levels are low-scoring students. Because they need to, like, if the problem is too hard, they should just not even try it. But if you're scoring, you know, not low, then you should never, ever worry about difficulty level. And, like, what I mean is that today should be the last time that you ever think about the difficulty level of a problem. You should never think about it again, unless you write tests. So it ends today. Like, the only reason that we tell you guys about that is because it justifies the timing strategy. Like, that's why we talk about adaptive tests and stuff like that. You don't have to know that stuff. You're not going to know that stuff. But it justifies the strategy that we give you. That's why. But don't think about numerical difficulty levels because they don't matter. All right, let's look at another question. How about this one? That one. Okay. Try, these answers are in minutes. So, go for it. I cleared your answers. Please, please, ladies and gentlemen, use the answer buttons to answer the question. That's these. Please use the answer buttons. Okay, here's a timer. There's not as many words in this one, so I'll give you about a little bit over 2 minutes. Okay, it looks like you guys don't love this one, but let's try to get answers in the next short bit. Say like next 15 seconds or so, let's try to answer this guy. Okay, we still have a lot of blanks here. Anand, Andrew, Kaliza, I think you just got here. Prabhakar, Rejul, please answer the question. A couple of you guys are the same names from last time, meaning that you're consistently not answering questions. Remember that you have to answer the question. So even if you are absolutely clueless, you have to guess, because that's how this test works. There's no non-answers on this test. So please answer the question. Okay, if you're one of those 4 people, again, if you're not answering, you're not preparing yourself. But here are some statistics for the class. So we're kind of all over the place on this one. So let's take a look. What's the situation here? Like, what are the quantities in the problem? Quantities? I mean, we have printer A and printer B. So, times for different quantities of papers. Okay, so we have a time for 40. Yeah, we have times to print 40 pages. So, time per 40 pages is a little bit interesting, but it's a start. And then, so we can take that and make that into a time per page. So, there. And then you've also got pages printed. And you've got time. So same thing here, number of pages printed and time. So, you know, this may not be the easiest thing in the world, but if you have time per page, what can you multiply that by? You can, time per page times what is going to equal what? Chat box. Time per page times how many pages equals total time. So number of pages equals total time. So what do we do with time per 40 pages? Well, so let's think about that. We've got the rate per the time per 40 pages is 40 times the time per page. So because the time per 40 pages is just 40 times as long as it takes to make one page. So this sentence that I'm about to highlight in green means that 40 times the time per page for A is 4 minutes longer than 40 times the time per page for B. Because it's the time for 40 pages. So we can divide that whole thing by 40 to give time per page for A is 0.1 time plus time per page for B. So let's let this be rate R. So if that's rate R, then for the rate for A is 0.1 plus R. So this would be R time per page for B, that's R, and that's 0.1 plus R, times how many pages equals the total time. Well, in 6 minutes. So the total time is 6. You can do division. So that's 6 over 0.1 plus r. This is 6 over r. And then you know that the number of pages is 50. So 6 over 0.1 plus r plus 6 over r equals 50. So that's kind of annoying. What you can do is you can multiply both sides by the product of those two things. I got this problem from this is not an official problem, by the way. But there's still a very nice way to solve this. So we'll look at that in a second. But if you do that, you get 6r plus 6 times 0.1 plus r is 50r 0.1 plus r. So it looks like it's going to be this ugly quadratic thingy. That's 6r plus 0.6 plus 6r equals 5r plus 50r squared. So that looks like 0 equals 50r squared minus 7r plus 0.6. Ew, this is gross. Okay, this is not, I bet you can, if you're better at algebra than I am, I bet you could keep doing this, but I don't think this is reasonable in 2 minutes. So let's talk about alternative approaches. So let's stop that. I mean, we could keep doing weird quadratic factoring, but let's not, because especially because we're running up against a time constraint here. Let's do this without algebra. Does anybody know how we could do this without algebra? Notice you can't really take the third grade. You can't do the third grade method here because you don't have hard rates. Like you don't have given rates. But what can you do as a backup method? You can use the answer choices. Let's do that. You can't assume a rate value because then you're probably going to assume the wrong value. Let's back solve. So start from an answer choice. Make sure you organize your approach. And then if everything works in the problem, then you are good. So when you plug in answer choice, that's going to be the time taken by how long it takes A to make 80 pages. So now we don't really care about that, we care about this. So therefore we can find how long it takes A to make 40 pages. And because that's just half of that, and then how long it takes B to make 40 pages. Let's make that a little bit smaller font size. There we go. Okay. And then once we have those, we can figure out how long it'll take to make 50 pages. So, how many pages, because we want 6 minutes. We want this to be 50 pages in 6 minutes. So how many pages for A in 6 minutes And how many pages for B in 6 minutes? Let's do this. Let's say, start with answer choice C, because C's in the middle. So 20 minutes. If it takes if it takes 20 minutes to make 80 pages, how long does it take to make 40 pages? It takes 10. It takes half as long. So then we have to subtract 4 minutes from that. So that takes B 6 minutes. So notice this is 40 pages in, 10 minutes. So this is 4 pages per minute. Here we don't need to figure out pages per minute because this is already 6 minutes. That's exactly the time that we want. So in 6 minutes, we know that B actually makes exactly 40 pages. So we know that A makes 4 pages per minute, so A makes 24 pages. So this is a total of 64 pages. That's too many pages. So which answer choices are gone? So both people who have responded are incorrect. We cannot eliminate D and E. Think about it. This means that your printers are too fast. If you make A or B, you're making your printers even faster than they are now. So this means your printers are too fast. So A, B, and C are gone. Because A, B, and C are even less time for the same amount of work, which is these are faster. So those are slower, those are faster. So let's try D. So 24 minutes. So that means that it's 12 minutes to make half as many pages. Minus 4 is 8 minutes. So A makes 40 pages in 12 minutes. That means it will make half as many in 6 minutes. You don't need to do 2 minutes here. So you don't need to do per minute. So if it's 12 minutes is 40 pages, then 6 minutes is 20 pages. Here, we have a per minute rate. We have 40 pages in 8 minutes is 5 pages per minute. So that number gives us 30 pages in 6 minutes. So together, we have a total of 50 pages. This is what we want. So done. It's D. And even if it weren't what we wanted, we would still be done, and it would just be the other choice. So either way, we're done. Back solving. Still not super easy, but it's good to get practice at this. So the main point here is this needs to be an instinct. If you get stuck on a word problem that has numbers as choices, then you should very quickly try back solving. You should try back solving right away. Back solving is very good. Okay, any questions about the back solving approach? One gentleman put another approach in the box, and I think that looks valid. Unfortunately, we don't have any more time in today's study hall, so for now we'll have to stick with I think that looks good. It's An Trin. I know I'm not pronouncing that right, but the gentleman with the Vietnamese name. Okay. Are there any questions about the back-solving approach? If not, we're going to shut the curtains here pretty soon. And oh, okay. Thanks. Well, I tried. I'm sure it was kind of wrong, or at least had a heavy accent. All right, we're going to close up shop here, and yeah, Bruno, you can access all of the recordings. In fact, the recordings are on the same page as you sign up for this on. It's all on one page. There's one giant web page for Thursdays with Ron, which has everything on it. Immediately no, it's going to be like however long it takes tech support to post it. But this is all one web page, like, so you just scroll down. So all of it's there. It's a very long web page. I have not watched the recording, so I don't know, but I'd imagine you probably can. Fast forward. It seems like you would be able to do that. So, all right, ladies and gentlemen, so we're done. If anybody has any quick admin questions, like administrative questions, business questions, whatever, feel free to ask. Otherwise, we got to run here. So I'm going to shut off the recording and enjoy the whiteboard page. That page, that page. Okay. Good stuff, guys. So we are out of here. I'll leave this page up for like maybe 2 more minutes, but I'm kind of on a schedule today. So recording's going to get killed.